Okay, so in this video we are going to look at combinations in probability. So we see here up at the top, these are kind of the three different forms it can appear in. The first two are the ones it is most commonly written as, but the third is also kind of a formula for working it out. So for part one here, we'll look at all three approaches. So this, we call it as N choose or, and here N C is for combinations, but also you call it choose or. And then this is n factorial over or factorial multiplied by n minus or factorial. So the first one here for 3 choose 1, we'll just put it into the calculator like this. So the choose button is, you'll hit the shift key and it's above your division button. So 3 choose 1 will give you back 3, or your alternative approach. Again, we wouldn't take this approach unless the question specifically asked for it, but it'll be 3 factorial. My OR value here is 1, so 1 factorial multiplied by 3 minus 1 factorial. Into your calculator, 3 factorial will give you 6. And then the bottom line we'll put in by itself, so 1 factorial multiplied by 3 minus 1 factorial will give back 2. 6 divided by 2 is 3. So the same answer there. Part 2 now, we have 6 choose 4. And your calculator, it's always the easier approach. 6 choose 4 will give me back 15. Or else my kind of formula method would be 6 factorial over 4 factorial multiplied by 6 minus 4 factorial. So 6 factorial will give you 720 divided by, and if I put the bottom line in, 4 factorial multiplied by 6 minus 4 factorial will give me 48. And then 720 divided by 48 will give me 15, the same answer. So that's kind of your basic approach to it, essentially the theory behind it. And then just maybe an important condition to remember for combinations, it's not in your log tables, is what's called the twin rule. So n choose or will give you the same answer as n choose n minus or. So into our calculator, 11 choose 8 is the same as, so that's our workings for the calculator. So 11 choose 8. So that'll be a question like if there's 11 players on a team, on a squad maybe, and we pick a team of 8 players. How many possible teams are there? So you'd have 165. And then here, 11 choose 3. Again, into your calculator will give back 165. Okay, so we'll look at some examples now. Part 1 says if there are 15 players on a squad, how many different teams of 11 can be chosen? So we have 15, choose 11. Into our calculators, we get back 1, 3, 6, 5 teams. And then here now in the second part, we've been given a condition. So they say how many different teams of 11 can be chosen if the captain must be on the team. So then it's going to be captain. And left over from the 11, we're going to have 10 players. So for this part here, it's 1 choose 1. We've 1 player. We want that 1 player. And of this then, sorry, it'll be 15 if we've taken out the captain, 14 players left. And it's 14 choose 10. Because 14 and 1 gives me my 15 players. 10 plus 1 gives me my 11 players. So just into the calculator, 1 choose 1 will give you back 1 multiplied by 14 choose 10. Which will give back 1001. So that's cut down just 364 teams. It's taken off the answer from part 1. Okay, and part 2 now, we have a debate club. It consists of 5 boys and 6 girls. A committee of 5 members is to be formed. How many committees can be formed if part 1 says no restrictions, and then part 2 is that there must be more boys than girls? Okay, we'll look at part 1 first. So 5 boys and 6 girls gives me 11 members, and they say a committee holds 5. So 11 choose 5. Into your calculator will give you back 462 for part 1. That's the answer. And for part 2 now, it's that there must be more boys than girls. So we're just going to write out these scenarios first. So if it's 5 members, we could have 5 boys, 0 girls. And then we're going to add, because when we use the word or in probability, it means we add. We could have 4 boys, 1 girl, 3 boys, 2 girls. And then we won't have 2 boys and 3 girls, as that would flip the balance and it wouldn't work for the criteria they've set us. So if we have 5 boys, in total we have 5 boys, so it'll be 5 choose 5. And then for 0 girls, there's 6 girls, and we're choosing 0, plus 5 boys, we choose 4 of them. 6 girls, we choose 1. 5 boys, we choose 3. And then 6 girls, and we choose 2. So into our calculator, and you can put it in its brackets. So 5 choose 5 multiplied by 6 choose 0 will give us back 1. 5 choose 4 multiplied by 6 choose 1 will give me back 30. And then 5 choose 3 multiplied by 6 choose 2 will give me back 150. So we add them together, and that's 181 committees will have more boys than girls. So there's some examples of conditional probability, combinations in probability, and that's us done.